Hello everyone. Today we are discussing a very important topic of data analysis, ANOVA and regression analysis. These are two fundamental methods used in data analysis to compare groups and to study relationship between variables. Let's begin with brief introduction. Data analysis insights. Data analysis helps to find a pattern, relationship and difference. There are the key tools: ANOVA analysis of variance, regression analysis. These are used for decision making and prediction in research. For example, is there a difference between the performance of a student in three teaching methods, or can we predict sales based on advertising expenditure? To answer such questions, we use two main techniques: ANOVA, which help us to compare groups, and regression, which help us to predict relationship. What is ANOVA? ANOVA stands for Analysis of Variance. It is a statistical technique used to compare the means of three or more groups. It helps us to understand whether the difference among these means is significant or just due to random chance. The concept was developed by Sir Ronald A. Fisher. For example, ANOVA can be used to compare the average yield of crops using three different fertilizers. Objectives of ANOVA. The main objective of ANOVA is to test whether all group means are equal or not. It helps to determine the effect of one or more factor on a dependent variable. In simple terms, it checks if the observed difference between groups are statistically significant. It also helps to minimize experimental error by separating the real effect of the factor from random noise. Assumption of ANOVA. Before applying ANOVA, we must ensure a few assumptions are satisfied. First one, data should be follow a normal distribution. Second, the variances of all groups should be equal. This is called homogeneity of variance. Third, the observation must be independent of each other. And finally, the sample must be randomly selected. Types of ANOVA. There are mainly three types of ANOVA. The first one is one-way ANOVA, which compare means of three or more groups based on one factor. For example, comparing student marks among three teachers. The second one is two-way ANOVA, which considers two factors simultaneously, like teaching methods and gender. The third one is MANOVA, which is multi-vibrate ANOVA, used when we have multiple dependent variables. ANOVA hypothesis. In ANOVA, the hypotheses are defined as follow. Number one, the null hypothesis H0 states that all group means are equal. That means there is no significant differences. Number second, the alternative hypothesis. The alternative hypothesis H1 states that at least one group mean is different. If F value is greater than critical value, reject null hypothesis and conclude that the group means are not equal. ANOVA formula. Understanding variance and analysis. The F-test in ANOVA is calculated using this formula: F equal to variance between group divided by variance within groups. If the between groups variance is much higher than the Within group variance, it means the groups are significantly different. If f is smaller, it means the groups are similar. The larger the f value, the stronger the evidence against the null hypothesis. Example of ANOVA. Let's take an example. Suppose we use three fertilizer A, fertilizer B and fertilizer C on different fields and measure crop yields. We calculate the group of means and overall means, then find the between group and within group variance. After computing the F value, if it is greater than the table value, we reject the null hypothesis. This means fertilizer type has a significant effect on crop yields. Now let's move on to regression analysis. What is regression? Regression is a statistical method used to study the relationship between two or more variables. It helps in predicting the value of one variable based on another. For example, we can predict sales based on the amount of money spent on advertisements. Regression is widely used for forecasting, prediction, and understanding cause and effect relationships. Types of regression analysis. There are mainly three types of regression. The first one is simple linear regression, which involves one independent and one dependent variable. For example, sales versus advertisement. The second one, multiple linear regression, which includes two or more independent variables such as sales based on price and advertising. And the third one, non-linear regression, where the relationship between variable is curved on exponential. Simple linear regression, understanding the equation and application. The simple linear regression equation is y equal to a plus bx. Here y is dependent variable, x is independent variable, a is the intercept and b is the slope. For example, if the equation is y equal to 50 plus 10x, it means x increases by 1 unit, y increases by 10 units. This simple model helps us to understand how one factor influences the another one. Multiple linear regression, understanding complex relationships in data. In multiple regression, we use more than one independent variable. The below are the general equation we used in multiple regression. For instance, sales might depend on both advertising and price reduction. This model helps us to analyze that combined effect of several variables on a single dependent variable. It is very commonly in business, economic and machine learning applications. Difference between ANOVA and regression. Let's compare ANOVA and regression. ANOVA is used to compare difference among group means, while regression is used to predict a dependent variable based on independent variables. In ANOVA, the independent variable is usually categorical, like group of or type. In regression, the independent variable is continuous, like price or time. ANOVA give an F static, which regression provide a prediction equation. Application of ANOVA and regression. ANOVA and regressions have a wide range of application. ANOVA is used in agriculture, education, medicine, and manufacturing to compare treatments or methods. Regression is used in business forecasting, economics, marketing, and data analytics to predict trends. Both methods are powerful tools for scientific and statistical decision making. To conclude, ANOVA and regression are fundamental tools in statistics. ANOVA help us to test whether there are differences among group means, while regression help us to study the relationship between variables and make predictions. Both techniques allow researchers and analysts to draw meaningful conclusions from data. In the next page, there are the following references. There are the following references you can use. Thank you for watching.